Next, we're going to discuss the unit circle. Before we do that, we have to take a look at the box here that says trigonometric functions on the unit circle. If t is a real number and x comma y is a point on the unit circle corresponding to t, then the sine of t is going to be equal to y. Cosine of t is the same as the x coordinate, and the tangent is going to be the sine divided by the cosine, or you could think of it as y divided by x. When we look at the reciprocal functions, the cosecant is the reciprocal of the sine. So we're just going to think of cosecant of t as the reciprocal of the sine. And we're going to think of secant as the reciprocal of the cosine. And then cotangent you can think of two ways. You can either look at it as it is the reciprocal of tangent, so it would be x over y, or you can just remember that it is the reciprocal of the tangent. Okay, with that in mind, now let's go and take a look at our unit circle, which is right here. Now for some reason, mine printed a little bit weird on here, but here's what we're looking at, this unit circle, which yours should be at the top of your circle. The unit circle is the equation x squared plus y squared is equal to 1, telling us that the radius of our circle, so anywhere from the middle of our circle, the center, which is the origin, out to our circle is a length of 1. And it doesn't matter where we go. Remember, your radius can be on a diagonal, it could be straight up and down. But all the radii are going to be 1. Now, let's take a look. Let's move this over just a little bit. And we're going to take a look at the unit circle at some different points on it, starting with right here. This is always going to be a rotation of 0. So this point right here is where we're starting. So we always start with the positive x-axis as we rotate around. So here's where we start, and then we rotate positive this way and negative this way, always starting with the positive x-axis. So this right here is going to be rotating 0 degrees. And if we rotate 0 degrees, we're looking at an ordered pair. Remember, our radius from here to here is 1. So this is the point 1, 0. Then if we rotate 90 degrees, it brings us up to the top right here. So this is 90 degrees. Remembering again, if we go from our center up here to our circle, that's our radius. That is a length of 1. So this ordered pair for 90 degrees is the point 0, 1. Rotating 180 degrees brings us over here. So this would be 180 degrees. And that ordered pair, remember from here to here, is a length of 1. But since we're going in the negative direction, this would be the ordered pair, -1, 0. And then finally, we come here. This is 270 degrees. And 270 degrees, this would be your point 0, -1. And then if we go all the way back around to 360 degrees, we have made it back to the beginning. So 0 and 360 degrees has the same ordered pair, meaning it has the same sine value and the same cosine value. And we can continue to go around and add degrees to it if we need to. Using the special right triangles we have on the top, we're going to create those special right triangles within our unit circle. So let's start with rotating 30 degrees. So if we rotate 30 degrees, let's say that that's right here. What we're going to do is we're going to drop a perpendicular down to the x-axis. Now your perpendicular will always be to the x-axis. So here's my right angle. And if this is a right angle, that means the angle up here on the top has to be 60 degrees. And using what we had created above with our triangles, we know that because this is the unit circle, this hypotenuse is a length of 1. So that means across from our 30 degrees is a half, and across from our 60 degrees, that length is the square root of 3 over 2. So my x value from here to here is square root of 3 over 2, and my y value is 1/2, giving me the ordered pair for this point, square root of 3 over 2, 1/2. I can look at a 30-degree reference angle in every single quadrant, but let's do one more together. If I go to quadrant number 2 and I draw in my reference angle, so I'm talking about this angle being 30 degrees, but the angle that's actually rotated is from here to here. So if I rotate from here to here, that's going to be 150 degrees. So I'm looking at an angle of rotation of 150 degrees with a reference angle of 30 degrees. I'm going to drop my perpendicular down to my x-axis. Remember, it's always the x-axis. And if I drop that perpendicular down and I know that this is 60 degrees, the only difference between the first quadrant is we have to worry about our signs. So now our x is in the negative direction. So if I'm across from my 60 degrees, this is negative square root of 3 over 2. This is still positive 1/2. So this ordered pair that I would get here would be negative square root of 3 over 2, comma 1/2. So let's take a look next at if we rotated 45 degrees. So if I rotate 45 degrees, I'm going to be right in the middle here. So this is 45 degrees. And then I drop my perpendicular down to my x-axis. And so here, this angle in blue is going to be 45 degrees, meaning this angle up here is also 45 degrees. So I have a 45, 45, 90 triangle with my radius again being 1, or my hypotenuse, which means that this point, or this length for y is square root of 2 over 2, and the same thing for my x, because they're both across from those 45-degree angles, giving me the ordered pair square root of 2 over 2, square root of 2 over 2. I could look at 60 or 45 degrees also in the second quadrant. So if I go in the second quadrant, I'm looking at my reference angle here. But if I'm looking at a positive rotation starting from here to here, I've actually rotated 135 degrees. So this is a 135-degree angle to get to here. If I drop that perpendicular down, I know that if this is 45 degrees, then this also is 45 degrees, giving me that square root of 2 over 2 and square root of 2 over 2. But what I need to remember is that this is in the negative direction. So the length of my x is negative square root of 2 over 2. And the length of my y is also square root of 2 over 2, which would give me an ordered pair at 135 degrees at negative square root of 2 over 2 and square root of 2 over 2. And remember, we can keep going. So I could put a 45-degree reference angle in here. I could put one in here. And I can continue to rotate around as many times as I need to. And this will make a little bit more sense once we start getting to the examples coming up next. The last triangle that we have to do or take a look at is going to be our 60-degree rotation. So if I go here and rotate 60 degrees, so now I'm looking at this area or this angle here. If I drop my perpendicular down, now I have my 60-degree angle here, which means my 30-degree angle is up here on the top. So it's basically going to be the opposite of what my 30-degree rotation was, because now my x is a half, where my y is the square root of 3 over 2. So I'm running out of room. But this point right here, you know what, let's take away. Let's do this. So this is 60 degrees, which would be your ordered pair. And I don't have room to write it down, but if you want to write it down next to it, your 60-degree angle would be 1/2, comma, square root of 3 over 2. And like I said before, if this is a little confusing, it should start to make sense as we start doing the examples. We could also do a 60-degree rotation here, which means that if we rotated from a positive direction, we have rotated 120 degrees. So this would be a 120-degree rotation, creating that ordered pair. If this right here, my reference angle is 60, that means this angle up here is 30. Since my x is going in the negative direction, this x is going to be negative 1/2. And then across from my 60-degree, my y value is going to be square root of 3 over 2. So that would give me the ordered pair negative 1/2, comma, square root of 3 over 2. If you want me to show you any more with this right now, please let me know. Otherwise, try looking at the next example and see if it starts to make a little bit more sense. If you have questions, again, let me know.